This is Dr. John Bergduff. We're going to look at some applications of divisibility. I want to show you two examples that are very, very different from one another, but both end up being connected to the concept of divisibility. So the first one of these is a word problem, and let's take a look at this and see what we think. The king of Babylon owns 23,716 sheep, and he also owns 11 very large walled pastures. Can he distribute his sheep into these pastures so that each pasture contains the same number of sheep? Now let's think about that for a minute. So what he wants to do is he wants to separate his sheep into pastures. Separating something out sounds like dividing something out. So he's trying to divide the sheep among the pastures. And he wants to make sure that there's no sheep, that every pen gets the same number of sheep. So if that doesn't happen, if he were distributing the sheep 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, there would be a leftover sheep or two at the end who would end up having to be in a pen that would not have the same equal number. That sounds a whole lot like a remainder. So when I am looking at this question, what I am seeing is that they're really asking me, can I divide 23,716 by 11 so that the result has no remainder or remainder equals 0? And that really boils down to the question, does 11 divide 23,716? So this is actually a divisibility question. Now I could get a calculator out and literally divide 23,716 by 11, and you might want to do that. But we also have the little trick we've learned about how to tell whether a number is divisible by 11. And there's a lot of different ways people say this, but the easiest way, I think, is to think of it in terms of alternating digits. Start with the first digit and take the alternate digits, every other digit from there to the end. Then take those numbers and add them up. So if I add 2, 7, and 6, 2 plus 7 is 9, plus 6, I get a sum of 15. Now go back and begin with the second number, and again circle the alternate digits, and add those up, and that would give me a sum of 4. Okay. Now the way the trick works is whatever two sums you just got, take the larger one minus the smaller one, so we'll subtract and see what we get. In this case, we're going to get an 11. Convenient. And the way the property says, or the way the property works, is that if the number you get when you do this subtraction is itself divisible by 11, then the original number was divisible by 11. Well, 11 is divisible by 11. 11 divided by 11 is equal to 1 with a 0 remainder. So 23,716 is divisible by 11, and the answer to this question, we don't even have to have a calculator. The answer to this question is yes. He can distribute his sheep, and there won't be any leftover sheep who don't have a place to go or a pen that has too many sheep. Hope that looks good. This one is different. Let me get rid of that. So, not a word problem, but sort of interesting. Fill in the blank with a digit from the set, and these are just the the whole numbers between 0 through 9, so that the resulting number will be divisible by 9. I don't know what goes in that blank, in other words. But I do remember from another divisibility rule that if you add up the digits in a number, and the sum of the digits happens to be divisible by 9, then the number itself was divisible by 9. So if I take a look at what I've got so far, 3 plus 4 plus 6, if I add up those numbers, I'd have a 13. I don't know what goes in that blank yet, so we've got to figure that out. But by that divisibility rule, if I could think of a number to put in this blank so that when I add them up, I get a number that's divisible by 9, then the original number was divisible by 9. So I think for a minute, and I think, well, I kind of need to think about what numbers are divisible by 9 and see if I can get one of those. 9's divisible by 9, but I can't add something to 13 that's positive at least and get a 9. 18 is divisible by 9. So if I can find something to put in that blank that would give me a sum of 18, that would be a digit that would work. And it looks to me like that digit needs to be a 5. So the number that goes in the blank is a 5. The number is 3, 4, 5, 6. 3,456. So I hope those were fun. Thanks.